So now let's introduce you to the concept of models versus entities. You'll notice that in our code here for our foods controller, that we're actually returning the actual entities that are being returned by the repository. We're exposing the actual entity objects we're getting from the database, the raw objects. And in some cases that might be fine, but it tends to overcomplicate it to return the entities. Often you're going to want to control what is being sent back to the users a little more. You'll see here when we call the API that we're returning just the foods themselves, right? We're getting these empty collection of measures. We'd like to actually be returning the measures as well. So let's do that. There's a call on the repository that is get all foods with measures. This goes ahead and includes the measures in the result. So we don't have to really change our result, but in this case we're now going to attempt to return an object graph. But when we look at our result, the serialization is going to fail. Now the reason it's going to fail is that it has found what's called a self-referencing loop in a property of our food entity. The reason is that often when you're building your actual data storage, let's go over to the food, we can see that food has a collection of measures, and that's fine. But what about measure itself? Measure has an instance of the food that's related to it, so that we can easily navigate from measure up to food, and from food down to its measures. But this is a circular reference as far as serialization goes. It looks at the food, goes, okay, I know what the properties on it are, then looks at the measures inside the food and starts to serialize them, but when it gets to food, it goes, it looks like I need a food related to measure, so I'm going to serialize the food, which then creates more measures and food and measure and food and measure, and it could go on forever. And so it detects these circular references, and it doesn't know what to do with them. There's a lot of ways you can solve this, and let's talk about a couple of them. Let's try solving this by just returning the data we want. Let's take advantage of link to use select. So I'm going to use select, and I'm just going to create a new anonymous type to return. And I will say description equals, so I need a lambda here for food. Notice that I'm cutting off the ID here because it may or may not be useful to include it. So we can decide about shaping the data here using this facility. Of course, the results doesn't like this because we told it we were returning an enumerable collection of food, but we're returning anonymous types as well, so we can just say object, because we are in fact returning a series of objects. And if we do this, we're going to run into the same problem, because our measures still reference a food object, which then references measures and foods and etc. So we need to actually do measures.select and follow that same pattern. And I'll just include a couple of properties here. I'll say description and calories equals m.calories. I could go and include them all, but this will tell it to go ahead and create a new collection from the measures that only include the data we want as well. So in this way, we're getting all that descriptive information we're getting around the serial recursion because we're deciding what actually belongs in the serialized objects. So for every 3 ounces of abalone that someone eats, it's 82 calories, and in the case of this juice I can't pronounce, 1 cup is 55, 1 fluid ounce is 6.9. You can see we're actually starting to get some information that someone using your API could actually benefit from. But this becomes pretty fragile, because you're going to want to return these new sorts of objects in a number of different places, and copy and pasting this in every place is going to be problematic. So maybe instead you want to return something more concrete. So let's go ahead and do that. Let's create a new model. There's a models folder here. Let's go ahead and create a new model class for food. And I typically take the name of the entity and postpend it with model. Some people like to use different words for it. I like to use model because it becomes pretty simple. And here I'll do the same thing I did before. I'll just use description. And notice I'm saying for the measures, I'm going to assume there will be a measure model. And in fact, I'm going to use the refactoring to give me that measure model. Let's generate a new type, call it measure model, put it in a measure model class. And here we'll do the same thing, prop. And we could include more options here, but for now that should be good. And then that means over here in the controller, all we need to do is instead of returning an anonymous type, we can just say food model. And because we use the same name, that'll just work. Let's bring in the namespace for models. And then the same here, new measure model. And this comes back to where we can actually tell it the type of enumeration, in this case, food model. We're essentially getting the same results back, but we're using concrete classes on the server so we can be a little bit sure that breaking changes are going to actually break something. Again, the problem with this approach is that we're telling it that we have some fixed creation of these models that we're going to end up having to copy everywhere. So instead of doing this, I like to use a pattern called a model factory. I'm going to create a new class and just call it model factory. There are a number of ways to kind of handle this. Many of you out there are probably already nodding back and forth thinking, well, couldn't we use something like AutoMapper for this? And in fact, AutoMapper is really interesting until you need to get information about the URIs or that include the request itself. And this is a pretty common case in Web API. We'll see this later when we talk about how we're going to use certain parts of the API. So instead of that, I'm using a method here where I can actually write a little code to determine how to build each of these different model types. So in the model factory, I'm going to have a public method that's going to return a food model, and I'm just going to call create, and it's going to take a food. So the use case here is we're going to pass in an individual food, and it's going to create an individual food model itself. So in fact, we're going to do basically what we've done here, is we're just creating a common place that we can do this. Return a new food model. Let's bring it here so it's a little bit more pretty. And then instead of creating the new model here, we're just going to say select create M. So when we do the select for measures, we're going to call the create on this food model to make this public because we're going to need it in other places. And we're going to do the same thing. And here we're going to say return a new instance of the measure model that copies in all the data that we really care about. The reason why this works well is it creates one place where all of this mapping between the measure and the food is happening. In fact, we'll do the same operation but in reverse when we need to take a food model and generate a food object, or really what I like to think of it as parsing into a food object for us. And we'll see that later on in the course. This works well because now our select becomes as simple as saying model factory.create and create the model for us. Let's go ahead and create an instance of this and say model factory equals new model factory. We'll get into later why we're creating this in the controller instead of creating it using dependency injection. Now, what you'll notice here in this pattern is that I'm telling the model factory to just create a food model for me, and then inside of this it will know how to generate the sub-object. In this case, it will know how to create the measures as well. And this ends up being fairly helpful in our construction of these objects, because later we're going to want to make some custom changes to the way that these models are generated in a variety of ways. For example, if we go back to the code in the model factory, we may decide that the calories may be a double value, but we want to always control the way it looks. So we may decide to just say math.round to make sure that the calories that we're applying to the user are actually rounded values. See, we've lost all the decimal places, and it's rounding to the nearest value now. Because we're creating these, we can then use this in the same way to handle other parts of our controller. So if we say public food model get ID, if we expose getting an individual food object, we can then just very simply say repo.getFood, which is going to take our ID, and this returns the actual food. So we can go ahead and say model factory.create and just wrap it to return our individual object, so that we're defining what creation of a food model looks like, but then we can use it in any of the cases where we end up having to return one of these food models. So we look at foods and go ahead and just say food with the ID of 1. You can see we're now able to return that same format. description, measures, each of the measures computed in the same way without having to worry about where we're handling all that mapping code. Let's talk about routing next.